Reaction set 3 will contain the last two types of synthesis reactions. In this first type, a nonmetal oxide plus water will form an acid. Remember, acids always start with H+. Nonmetals are everything to the right of the zigzag line, so things like carbon and sulfur and nitrogen. So in this case, we're going to make an acid with these reactants. And if you look on the reactant side, you have CO2 and another oxygen. That would give you CO3, which is the polyatomic carbonate. So to cancel those charges, you would have H2CO3. And to name the acid, if this is carbonate, any polyatomic that ends in ATE, when it's in an acid, you change the ending to IC, so it would be called, instead of carbonate, carbonic acid. In this example, N2O5 or dinitrogen pentoxide will form an acid, and so we have H+1 there are two nitrogen containing polyatomics, so it's either going to go with nitrite or with nitrate. And if you look at the number of everything on the left side, you have N2O5 plus another O. That would give you N2H2O6, or if you reduce it down, it would be NHNO3. So your acid is HNO3, but you just have two molecules. And because the polyatomic in the acid is nitrate, you change the ending again to IC, and this is nitric acid. Sulfur dioxide, SO2 plus water, again H+1. If you look at what's left, you have SO2 and another O, that's SO3, the polyatomic sulfite. And so to cancel the charges, you would need H2SO3. Because this polyatomic is sulfite, an ITE ending changes to OUS when you have it in acid. So this is sulfurous acid. Water and dichlorine pentoxide are mixed. So if you put all this together, you would have H2Cl2O6, or if you reduce everything down, you would have HClO3. So that would be your formula, and you just have two molecules of it when you go to balance. This polyatomic is chlorate, so change the ATE to IC, and your acid is chloric acid. Sulfur trioxide is added to water, SO3. So again, if you have H+1, you have SO3 and another O, that would be H2SO4. Or if you just add up what you have on the other side, you have two H's, one S, and four O's. And so because this polyatomic is sulfate, again, you change the ending, and it's sulfuric. Remember, they add the UR just to make it sound a little better, so it's sulfuric acid. The last type of synthesis reaction is a metal oxide plus a nonmetal oxide to form a salt. Metal oxide might be sodium oxide, Na+1O-2, so it's an ionic compound. A nonmetal oxide is covalent, like carbon dioxide. And if you're going to make a salt, the salt is any ionic compound, so you have to have a plus and a minus ion for the salt. Sodium is the only thing that's positive in this reaction. It's the only positive ion. And if you look at everything else that's left, you have CO2 and another O, so that gives you carbonate. And so your formula would be Na2CO3. So the salt that forms is sodium carbonate. Calcium oxide plus sulfur trioxide. Again, the only positive ion is calcium +2. And if you look at the rest of what you have in the equation, you have one S and four O's, so that's sulfate. And so your compound will be calcium sulfate. So the salt is always containing a polyatomic that has oxygen in it, like sulfate. Solid potassium oxide is added to a container of carbon dioxide. So your only positive ion is the potassium +1. If you look at the rest of what you have, it's CO2 and then another O, so that's CO3 -2. So to finish the formula, it would be, when you cancel the charges, K2CO3. Magnesium oxide plus is added to sulfur trioxide gas, so magnesium +2 is your only positive ion. SO3 and another O would give you SO4 -2. And so the formula would be MgSO4, magnesium sulfate. So sulfate is your polyatomic. The last example is calcium oxide plus diphosphorus pentoxide. Calcium is your positive ion. And the polyatomic for the salt would have to be something containing phosphorus and oxygen, so it might be phosphate. It might also be calcium plus 2 with phosphite minus 3. So you might just sometimes have to try both combinations. If I were to make the combination of calcium and phosphate, plus 2 minus 3, I would have to go to plus and minus 6. And so I would need 3 calciums and 2 phosphates to make the formula balanced, the charges balanced. If I were to do it with phosphite, same ratio. But one of these will balance and the other one will not. And so on the phosphate, if I balance the calciums, and then I would have 2 phosphorus, 8 oxygens on this side, and I already have 8 oxygens on that side. So the first one works. If I were to balance the one with the compound with phosphite, I would balance the calciums. That would give me again 8 oxygens on this side, and I only have 6 oxygens on this side. So this one does not work with the number of phosphorus and oxygen atoms you have. So it would be the top one, and your polyatomic would be phosphate. On page 2 of reaction set 3, you'll find some of these 2 synthesis types. The metal oxide plus non-metal oxide gives you a salt, or the non-metal oxide plus water gives you an acid. You'll also find some review equations from the first 2 sets, reaction sets. So remember to complete and balance the equations and then tell which type of reaction each one is.